B. Which ring will be A? If we draw 4 ring structure, which ring will be A? 4th one, isn't it? So it is in anti-clockwise. So how many hydroxyl groups are there? How many hydroxyl groups are there? 4 hydroxyl groups. Go to the structure. Let us verify. So we have down 1, 2, 3 and 4. Isn't it? So 4 hydroxyl groups are there. How many ketonic groups are there? C double bond 2. How many ketonic groups are there? 2. So when you are asked to write about the chemistry, you have to draw the structure and you have to give the what are the connectivities. For example, you have a carboxamide group means C double bond ONH2. Then enolic OH means enolic OH. Then numbering. As I have told you, the last ring will be A ring. It goes in anti-clockwise and the numbering starts with the ketonic group. Okay, first numbering goes with C double bond. So coming to the mechanism of tetracycline, it inhibits the protein synthesis. So what does it inhibit? Protein synthesis. What does it inhibit? Protein synthesis. So what it will do is it binds with the 30S ribosomal subunit and the enzyme involved is aminoacyl-tRNA enzyme. So your step involved is translation. That means your synthesis of protein is inhibited by the transfer RNA has to give the message to the messenger RNA. There itself it has been stopped. So what is the step is translation step. What is the step? Translation step. And what is the unit involved is 30S ribosomal subunit. What is the unit involved? 30S ribosomal subunit. And what is the enzyme involved is aminoacyl-tRNA enzyme. So from the transferase to the messenger. So messenger will carry the amino acids. So there itself it has been stopped. So the mechanism is the translation step is affected. What is the step affected? Translation step. So if you are giving more, as we have studied in India, we are prescribing the antibiotics like narrow spectrum and broad spectrum. Tetracyclines comes under the broad spectrum antibiotic. Tetracycline comes under which category? Broad spectrum. Broad spectrum antibiotic means it can inhibit both gram-positive, gram-negative bacteria. It can also inhibit gram-positive and gram-negative. When you take the disadvantages, antibiotic resistance. What is the disadvantage? If you are going on giving the dosage, it will be resisting. The bacteria will be resisting. So this translation step, so that only we are having more number of antibiotics. We have a chloramphenicol which is also inhibiting the peptide synthesis. Okay, this picture depicts like where the tetracycline is going to interfere in the protein synthesis. So what is the unit? It is 30S ribosomal subunit. And what is the enzyme is aminoacyl-transferase enzyme. And which step means from the transfer RNA to the messenger RNA. And what is the step called as translation. So this is the mechanism. Then coming to the uses. If we can go to the uses and then we see these are, yeah, you can go to the previous slide. See, these are the examples which include what is the antibiotic. You may get a question in your competitive examination. Cephalosporins, tetracyclines, and then neomycin, erythromycin, penicillins, vancomycin, all these, the listed antibiotics displayed in this table, they are isolated from the microorganism. So the source will be what? Microorganism. So in interview, somebody asks you, what is the, give me an antibiotic which is isolated from the microorganism, which is the beautiful example is penicillin. So penicillin is isolated, penicillin was isolated from Penicillium notatum. What is the penicillin source? Penicillium notatum. So when you take streptomycin, it is otherwise called as actinomycetes. It is otherwise called as actinomycetes. So the microorganisms. So when you see the drug discovery task, what is the source? You will be astonishing to see that isolation of microorganism places a good role in the sources. So these are the few examples and where it acts. So we Thank you.